Hello, geometry students. Welcome to Chapter 2. This chapter is on parallel and perpendicular lines. So in Section 2.1, we're going to focus on parallel lines. So we're going to go through some vocabulary. So we have parallel lines. They are lines that do not intersect, right? But there's something more about that definition. And hopefully you know that word would be that they are coplanar. That's an important part of the definition, and you'll see why when we get down to skew lines. Okay, so blank are used to indicate the lines are parallel. So we're looking for the symbols, the notation. So as you see here in the book, they often use what kind of looks like a triangle or a solid arrow. When I draw them myself, I just make a mark like that. That looks like an arrow. If we have multiple pairs, on this diagram, I can do this and then do a double arrow. And we usually have them go in the same direction. Okay, to show that these are parallel and these are parallel. But the ones with the single mark are not parallel, obviously, to the ones with the double mark. If we're writing that two lines are parallel, we use this double bar symbol. So here I can say line AB is parallel to line CD. Parallel planes. They are planes that do not intersect. And again, we use that same notation. You'll see there's a couple of ways that we can name a plane. Here, when you see the capital letter over off to the side, remember, plane does not end. It keeps on going in all directions. But of course, for drawing purposes, we have to give it what looks like sides. So when you see that capital letter in a corner, that's the name of the plane. So plane J, again, the double bar, is parallel to plane K. So now skew lines. Skew lines are also lines that do not intersect, but they are non-coplanar. So that's why it's important that when we define parallel lines, we define them as coplanar lines. Okay, big difference here. So for example, if I look at, let me take some of these markings away. If I look at line WT, okay, that's this line here. That line would be skew with line UQ. Here's UQ. And you can see how this line and line WT would never intersect, and they're not in the same plane. They're in two different planes. Okay, the next one I chose was line VR. And let's see, I went with line SP. They would not intersect, and they're in different planes. I also went with TR. So keep in mind, you don't have to go with just the segments in your drawing that are drawn in. Okay, I can use the diagonals from corner to corner. I can use a diagonal from S to V. Okay, there's lots of choices here besides the ones that have been drawn. So think outside the box. So I chose TR and WS. Again, they will not intersect, and they're in different planes. So name all segments parallel to AE. So I've got HD, FB, and CG. Two examples of parallel planes. So let's see what I went with. And there's multiple ways to name these, right? You can choose any three letters on the plane. So I have each HF. Okay. But again, there's lots of other combinations that could be used. But 3 points define the plane. So EHF, and I went with ABC. ADH, So ADH is the plane over on this left side. So that would be parallel to this plane, which I named FBC. Name all segments that are skewed to GH. So again, we want to think outside the box here. What do I have? I have FB. Okay, that clearly will not intersect and is in a different plane. AE, AF, EB, AC, and BD. Now if you see others that I didn't think of, put a little star next to this problem or highlight it and share that with me during class. Name all segments parallel to JK. So JK is here, and we have the end of this prism is the shape, has 5 sides. Do you remember what that's called? If you said a pentagon, you are correct. So this is a little tricky. I came up with OP, and then I also threw in NL, KP, oh, I'm sorry, I'm looking at I moved the wrong one. Okay, so where was I? OP, 1JK, so OP, NL, NSQ. Okay, now all segments parallel to NS. So here we have a lot of choices. We've got MR, LQ, KP, and OJ. Name a plane that is parallel to plane JKL. So we've got JKL, and again, there's lots of choices in how to name the plane. You just need 3 points, and I went with OPQ. Name 4 segments that are skewed to RQ. So here's RQ. So I went with NS. Okay, you see how they will not intersect. They're in different planes. JO, KP, and JK down here. So none of those lines will intersect with RQ, and they're all in different planes from RQ. So again, maybe you have other segments to add to this list, because we're only asked to name 4. So again, if you'd like to share that during class, put a little star next to this problem or highlight it and then share it in class. Okay, a transversal. A transversal is just a line that intersects 2 or more lines. So in this drawing, the example would be line T. Line T is the transversal that intersects line L and line M. So in this section, we're going to talk about some famous angle pairs. The first pair is called corresponding angles. They're angles that are on the same side of a transversal and in the same position. So if I start with angle 1 corresponds with angle 5. Do you see how they're both on this side of the transversal and they're in the same position, meaning that angle 1, if I think of it as being above line L, angle 5 is above line M. For angle 2 corresponds to angle 6. They're both on the right-hand side of the transversal, and again, 2 is above L, 6 is above M. Angle 3. If I look at angle 3, it corresponds with angle 7. They're both on the right-hand side of the transversal. 3 is below line L, and 7 is below line M. And then lastly, angle 4, that would correspond with angle 8. Alternate interiors. Alternate interiors are angles that are in the interior, meaning between the two lines, okay, in this case line L and line M. So 4, 3, 5, and 6, they are all interior angles. They're also non-adjacent, and they're on opposite sides of the transversal. So they have those three characteristics. So 3 and 4, they cannot be alternate interiors. They're interiors, but they're adjacent. Okay. 3 and 6, they are not alternate interiors. Again, they're interiors. They're not adjacent, but they're not on opposite sides of the transversal. So if I'm going to start with angle 3 would be an alternate interior with angle 5. They're on alternate sides of the transversal, they're non-adjacent, and they're both interior angles. So that leaves the other pair to be angle 4 and 6. Okay, alternate exteriors. It's a similar concept, but now instead of being on the interior, they're on the exterior. So our exterior angles are angles 1, 2, 7, and 8. Again, they have to be non-adjacent, so we can't say 7 and 8 are alternate exteriors. And they have to be on opposite sides of the transversal. So I can't say that 2 and 7 are alternate interiors. They're on the same side of the transversal. So if I start with angle 1 is an alternate exterior with angle 7. Angle 2 is an alternate exterior with angle 8. Our last pair is called consecutive interiors. They're also called same side interiors, so keep that in mind. So we'll put that off to the side here. You may see either name. So they're interior angles that are on the same side of the transversal. So if I look again back at my interior angles, same side of the transversal, that means angle 4 would be same side interior with angle 5. Angle 3 is the same side interior with angle 6. So for right now, we're going to focus on identifying these types of angle pairs. We'll go further with this when we start talking about what happens when L and M are parallel. So what I'd like you to do on this next page is identify what type of angle pairs all of these are. So for A through F, you're using this diagram, and then it starts with A again. A through J, you're using this diagram. Here's an important note. Remember, angles must belong to the same transversal to be an angle pair. So when you're looking at this more complicated diagram, if I look at angle 3 would not have any relationship with, say, angle 15, because they do not share a transversal. Right? Angle 3 has this transversal or this transversal. 15 either has line D or line B as a transversal. So pause the video, fill in this column with the names, and when you're done, come back and we'll compare. Okay, let's see how you did. Here we go. So 1 and 8, alternate exteriors. 2 and 3, same side interiors. You can go through and check the answers. If you differ with anything that I have here, again, put a star next to it, highlight it, and we'll discuss it in class. Okay, now we've got some always, sometimes never questions, and then some more with our angle pairs. So go ahead and try these. Pause the video again. When you're done, come back and we'll compare answers. Just take note here in number 7, I believe this is supposed to be angle 11. We're going to go with angle 11. Okay, let's see how you did. So again, check through your answers. See if you have anything different If you do, make note of it, and we'll talk about it in class. Okay, so now we're going to move on to some proofs. Okay, so we have a proof here for the alternate interior angles theorem. So what I did is I gave you the statements on this one, and then we're going to go through and fill in the reasons. Okay, so we're given that angle M is parallel to angle, or I'm sorry, we're given that line M is parallel to line N, and we're asked to prove that angles 1 and 2 are congruent. 1 and 2 are alternate interiors, so we are proving the alternate interior angle theorem. So our first statement, line M parallel to line N, we all know that's the given. 1 and 3 are supplementary. And how do we know that? If we think back to our angle pairs, what kind of pair are 1 and 3? They are same side interiors or consecutive interiors, and you can abbreviate. So you can do consecutive for interior, I do INT, angles theorem, and I abbreviate theorem. Okay, so the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. Do you remember the reason for that? Remember, when it follows from what was stated in the previous line, it's most likely the definition. We stated that the angles are supplementary, then we're stating what that means, so that comes straight from the definition. The measure of angle 2 plus the measure of angle 3 equals 180. Now that is not from anything previously stated in the proof, so let's take a look at the diagram. 2 and 3 are adjacent. Okay. The two angles form this line. They're non-adjacent sides, form this line N. So do you remember the reason for that? It's the definition of a linear pair. Okay, line 5. We have the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. If you look at lines 3 and 4, it's as though we put these two together, and what allows us to do that? The fact that both sums equal 180. So here you have two choices. You can use the transitive property of equality, or you could use the substitution property. Either one would be fine here. Line 6 comes directly from line 5. If we take away the measure of angle 3, we end up with the measure of angle 1 equaling the measure of angle 2. And taking it away means we use subtraction. And then lastly, do you remember when we changed from equality to congruency? That's the definition of congruence. Okay, let's see what's next. Okay, so I'd like you to try this one. This is a proof of the corresponding angles theorem. We're given again that lines M and N are parallel, and we're asked to prove that angle 1 is congruent to angle 2. They are corresponding angles, so we're proving that theorem. It's very similar to the last one. So go through and see if you can come up with the statements and the reasons on your own. Pause the video, and when you're done, come back and we'll compare. Okay, let's see how you did. You might want to pause again, take a look at this, compare yours to mine. Again, if you have any comments or notes, or if you did something slightly different, put a little star next to it and share it with me during class. Okay, lastly, we have 2 more proofs, and I'd actually like you to try these on your own. And I think we will start off class with these on Tuesday, next class, okay? So go ahead and try these 2. I'm going to end the video at this point, and you know, if you're stuck, that's okay, but at least try to get started. See what you can come up with. Make a plan. I actually think the second proof is probably a little bit easier. You might want to start with that one. It's up to you. But come up with a plan and then just try to put your plan into a series of steps, logical steps, with reasons that back up each one of your steps. Okay? So give that a try, and then we'll go through them in class. Don't forget to submit your notes. I hope you enjoyed the lesson and enjoy the rest of your day.